Hi, my name is Alex, and I'm working on a party builder strategy game. This game combines my favorite parts of 4X strategy games and party-based RPGs, and is set in a high fantasy world. This project started out as a 2D pixel art prototype, but evolved into a fully fledged, low-poly 3D game. Last devlog, I went over advanced mechanics, shader programming, and world features. This time around, I'll be discussing more mechanic changes and my implementation of enemy AI using goal-oriented action programming. It's a big episode, so sit back, relax, and let's get into it. I had some ideas to streamline the game's mechanics before writing an AI system. Simpler mechanics would be easier for the AI to comprehend, and also makes the game just feel better to play. What's the point of a good enemy AI if the human players don't even like the game? I started by simplifying the glyphs. I originally had 8 of these: battle, defense, healing, nature, mining, travel, trade, and worship. I cut this down to only 6 glyphs by removing travel and worship. I also combined all the glyphs into 2 categories: combat and worker. Each tile can have one of the 2 glyph categories. When the user selects a tile to spawn a unit onto, they also get to choose one of the 3 glyphs present in that category. This way, we go from 6 different tiles to hunt for, down to only 2, giving the player even more strategic control over which units they spawn. I also made it so tiles with buildings cannot also have a glyph. This gives more value to buildingless tiles in the game. Also, meadows no longer hide the glyph icon. I also made some changes to how buildings work. Before, buildings would change allegiance whenever a player moved a unit onto them. Players would lose when they no longer had any buildings. It would be very easy for a player on the run to just pick up a bunch of forests to stay in the game. But now, there are 2 types of buildings: passive and active. Passive buildings work the way I just described, but active buildings must be attacked and their health reach 0 before they fully heal and change allegiance. Enemy units cannot traverse on an active building, and players lose when they no longer have any active buildings left. Passive buildings no longer keep a player in the game. The last mechanic I streamlined was patrons. Patrons were conceptualized as local spirits that units in the worship glyph would interact with. Units could generate favor with a nearby patron, and the player with the most favor would be that patron's favorite. A patron would provide some buff to its favorite player within a local area called its domain. I designed it this way to be a counterbalance to artifacts. Localized but more powerful effects that can change hands, as opposed to global, immutable effects. The problem was that patrons were just too much of an investment for not enough payoff. So I made a few changes. First, I removed the worship glyph, and made it so any unit can generate favor in a patron's domain. Each patron also has a favorite type of unit. For example, units with a certain glyph, or units holding a certain type of item. These favorite units generate additional favor when in the patron's domain. Speaking of which, a patron's domain now only determines which units contribute toward favor. The patron's effect is now global to the entire map. This solves the issue of investment versus payoff, because the player no longer has to invest in specialized units, and they get an effect with global range. I also copied my player border shader code to render patron domains on the world map. So, funny story, I realized I forgot to mention a new mechanic I had developed in the last devlog. I really like how the leaders in Civilization grant you extra abilities that drive gameplay styles, so I decided to implement my own version in this game. I call this system Fates. It's themed like selecting a tarot card at the start of the game, where each card grants you special abilities. It's like a free artifact with multiple effects. Now, I say tarot cards, but all the cards I design are themes I made up. The Berserker has abilities that help you focus on aggressive combat. The Forager boosts your harvest ability from forests and meadows, so on and so forth. The cards themselves will be illustrated by me in a style inspired by Luke Humphreys and the Salamander King. I mentioned these artists in part 2 of this series, and you can find links to their works in the description. I really enjoy their thick line work, bold colors, and cell shading. Illustrating the cards isn't high on the to-do list for this game, but I know I'll have a lot of fun when I get around to it. After implementing the fates, I decided to model some more units. I wanted to have a presentable project before developing the AI. I'm closing out all of the systems involved in this game, so I'd like to start removing development placeholders and implement actual in-game content. This time around, I modeled Stalagmus, Alficra, Condalure of the Star Nose, and Lady Damia. I use a program called Blockbench to make these models. Blockbench is a free, open-source 3D modeling program for low-poly models. I use this instead of Blender because I'm going for a more low-poly look. This is my first 3D game, so I'd like to keep the modeling as simple as I can. That being said, I'm very proud of these models. I really tried to challenge myself with these. I learned how to texture details better on Stalagmus and Alficra. Condalure started out in a more relaxed T-pose, but I was able to pose him with some difficulty, and gave him a little staff. It's got a health potion hanging from it. And finally, I practiced proportions and modeling with Lady Damia. The hardest part with her was the neck area. I modeled the body and the head separately and had to find a way to connect them into a single mesh. But I'm very proud of these models and how far I've come from the first few. And we're finally here. Enemy AI. I've been putting this off for so long because I've never written computer player logic for a game this complicated before. I needed to do some background research first. I heard somewhere about goal-oriented action programming, or GOAP. This became the starting point for my game's AI design. GOAP is a programming pattern where you build possible courses of actions as trees, where each node is a potential action the AI can take. The AI then traverses the tree and selects the path based on some score, possibly a benefit to cost ratio. That path then becomes the AI's strategy. I'm simplifying here because that process alone isn't enough for my game, but now you have the basic idea of how it'll work. I found a great video from a channel called Game Dev Chats, and it talks about GOAP programming and other AI basics. I was watching this video on my TV while writing notes for the AI system. GOAP is cool because it's modular and relatively simple to implement. It's all based on trees, so I don't need any heady or computationally expensive deep learning models. However, GOAP requires prediction in order to work really well. Prediction is when the AI player looks ahead to determine the consequences of its own actions before actually changing the live game state. This is easy to implement in a game like chess or checkers, where there aren't so many rules. But my game is bursting at the seams with rules and systems and subsystems. So how can my game AI safely make predictions? Oddly enough, the events system saves me here. I wrote the game to be fully moddable, and was very inspired by the Minecraft Java Edition source code. All abilities and other effects in my game are written inside event handlers and loaded into the game via an external jar file. This keeps the game moddable because all the base content is a mod in and of itself. But events can help the AI make predictions because they each have a descriptive name. Whenever a unit takes damage, they fire off an event called Take Damage Event. The AI can intercept all fired events during prediction time and analyze the names to determine the consequences of any given action. So now my game AI can make predictions to assess the consequences of its potential actions. But how does it come up with actions to evaluate? That system relies on two classes of objects, goals and plans. Goals are overarching, abstract behaviors that generate a plan. A plan is a series of instructions that the AI will follow to completion. It's the path that I mentioned when I described GOAP. For example, let's say I wanted to write a collect resources goal. It would generate a tree of possible instructions, then use prediction to determine its best path. That path becomes the plan. The possible instructions would include a move command to each tile within the unit's range. The predictor would then determine which items are generated if the unit waits on that tile long enough. If an item is generated, then it scores that plan highly, and if no item is generated, then it scores low. I implemented a ton of goals to make the AI more nuanced at playing the game. Then there's a layer that sits on top of the goals and plans system. I call it the statistics tracker. The tracker keeps an eye on its performance throughout the game, noting things like gold income, units killed, units lost, etc. It then swaps out goals based on how things are going. Once I implemented all that, I had a basic functioning AI. I went back and implemented the effects for all the items, abilities, units, buildings, patrons, and artifacts in the game. This forced me to implement minor systems, such as critical hit chance, reduced visibility at night, status effects, and many more. The AI was able to understand and play around these systems pretty well, and even surprised me with some of its actions. I was not expecting it to attack my units even though I had programmed that as an option. All in all, the AI was a success, and I could finally move on with the rest of the game. I've been putting off giving this project a name for so long. Ever since the prototype, I referred to it as the Kingdom game. But that just won't cut it as we draw closer to launch. A game's name needs to be iconic and grab the potential player's attention. Also, a lot of RPGs are named after some proper noun relevant to the story or lore. I have a lot of ideas for world building and story for this game, so I'll pull from that to choose a proper noun. The game's history is based on real-life cultures, but passed through a fantasy lens, much like how Tolkien adapted Western European history and mythology for his Lord of the Rings mythos. I wanted to derive this proper noun from the earliest recorded human speech that we know of. Naturally, I went straight to the ancient Sumerian tablets, but I couldn't find any pronunciation I was 100% confident with. So I looked to the Afro-Asiatic language family and went down a rabbit hole of ancient Egyptian and related languages. My best friend is Ethiopian, so he was able to help me get context for a lot of this. Did you know that Hebrew, Arabic, Aramaic, Amharic, and Tigrinya all live on the same branch of the Afro-Asiatic family? Now you do. Tangents aside, I searched through the Thesaurus Linguae Egyptiae? Something like that, for words that translate to something relevant. I settled on Ta'anch, or Land of Life. I bounced some ideas off another friend of mine, and we shortened this to the name of the game, Legends of Ton. From here on out, I'll refer to the game by this name, but this episode is already way too long, so I'll cut it off right here. Stick around if you like to follow this project. Thank you so much for watching, and I'll see you next time. What's this? A special secret final section to the video? That's right, and it's an announcement section. I have an announcement to make. Legends of Ton is officially in open alpha. It's a bit of an open secret that I produced these devlogs super late, and I've actually been further ahead on development of the game than the videos show. This version contains a ton of additional work that won't get covered until the next video, so keep that in mind if you'd like to avoid spoilers from my silly little devlog series. I appreciate any feedback or bug reports you may want to send my way. Thank you so much for watching, and I'll see you in Ton.